top and bottom, right? Correct. So let's look at, we want to learn how to implement a stack again today, but with different type of data structure. So let's look at what have we learned so far about data structure. So last time we talked about stack. So what do we use? We use an array, right? To implement. Do you think you only learned array so far? Correct? You already know array. Alright, so let's look at this slide. Not that one. That's all right. You guys heard about linked list. So this is another type of.
Oh, it's not on the screen, Professor.
So we have array, we have linked list. This is another type of data structure. Pretty much how you store the data. So we know array, you store data in a term of like grids, right? Like table and grids, right? So let me insert tables. This is an array, right? Or if I would say, if I minimize that, it may look alike better. And then this is your index 0, 1, 2, right? And so on, right? And you put an element into it. Now, let's think about, if I do the ordered list when I insert like Andy, if I want to insert Kathy, George, alright. If I want to insert Bob, where would Bob go? Meaning that I have to shift the rest down, right? And then I have to add Bob here, right? But shifting this down is meaning that before Kathy was index 1, right? I have to copy Kathy to index 2 and George to index 3. Now if the list is like a million of people, would that be efficient? I have to shift like maybe 900,000 of them down every time when I insert a new person. So array will not be really efficient in that case, right? Because it will take time, right? So how about we create another type of list? This list, go to whole. It's going to be easier if I can draw. Okay. Watch this. Let me see if I can use paint. Now this list is going to hold the data and the elements. I mean, the elements of data, sorry, and the pointer to the next. Like this is the pointer to the next element. this is the next element. So it's going to hold the data and the element again. I mean, the data and the pointer again. And this is a pointer to the next data. Alright. And this is called a linked list, right? It's a list that is linked by the pointer. Okay. Now the pointer pretty much be like have an error. Like that, right? It's pointing to the next one. So, do you see, if I want to insert, okay, like, again, this could be, let me put that text. This could be, like, Andy. Right, Andy could locate here at the first node. We call node, first node, right? And then we have Kathy. And we have George. Now, George happened to be the last one. So, there's no pointer pointing to the next element. So, we normally assign null, which is slash like that. This is called null. For like each node has the elements and the pointer. Right. This one has no pointer because there's no next node, right? If I want to add Bob, right? So pretty much I create a new node, right? Which has a pointer too. And this is going to name Bob, right? And add the elements name Bob to it. But this is an order list, right? How do we insert Bob into this?
Where are you inserting Bob? You're inserting at the end of the list? In which case it just goes to the end.
If you insert at the end, then it's in order.
Yeah, if you want to insert it somewhere else, you have to change the order.
But we know that Bob has to go between Andy and Caddy, right? For the order list, right?
Yeah.
Now pointer goes to Caddy and A.
Right, so we're going to erase this by changing the value that at Andy node for the pointer to point to Bob, right? And then set the new pointer of Bob, right?
I have a question.
To point to Kathy.
Is this how computer memory stores this? So if I change an order list, is the computer memory just changing the pointers, or is it actually changing the physical memory locations? Like Kathy is not being moved from index 1 to index 2, it's still at index 2. It's just the pointer showing it as being third index instead of second.
Correct. That's why it's better than array in the term of it doesn't have to shift. Right? If you shift, you pretty much just change the address, right? But now, the address of Kathy stays the same, the address of George stays the same, right, in the physical memory. The only changes is just those variables that you store the values of the pointer at node Andy and the variables of the pointer that you store the value at node Bob. That's it. You just say, hey, Andy, you point to the new address of Bob. And Bob, you point to Kathy address, which is, it was Andy pointing to before. Then this is called a linked list. That makes sense? You're just switching two values, that's it. Instead of, like, if this list has a million of people, it's too easy by just changing two values. Instead of shifting them all, right? So this is called a linked list.
The linked list, don't you have to start at like the head?
Right, so we have, this is called head, right, or the beginning of the list. And this is called tail, which is at the end of the list. Okay. So we have head and tail. Yeah, the problem with linked list is you can see that it's not easy. If I want to get to Kathy, like in an array, you can just specify index 2, right? You get Kathy, right? But this one there's no index. You have to iterate through Andy, Bob, and then we get to Kathy. Always start from head. That's why we have the pointer show head. This is the beginning where you want to iterate, right? Iterate through the list.
Can you cut the list in half and see which one to start iterating on? Or no, you always have to go through the head?
That one is called BST, binary search tree, which we will cover that. Okay, so now, any question on linked list? And we see linked list and we see array. Let me just copy this and put it back in here. Right, so that's linked list, this is array. And both of them we use to implement what? An order list. So, I mean, you could do linked list, you could use array, you still be able to do order list. This is just for adding operation, right? So last time we were talking about stack, right? So it should be the same. You could use array to implement stack that we did. We also should be able to use linked list to implement a stack. Right, so the same thing, we just look at, instead of looking at this vertically, I mean horizontally, we just change it to vertically. Right? That's become a stack, right? Andy, Bob, Kathy, George. But any order you can just keep pushing, right? You insert at a head, that's where your top, right? Whenever you insert a new node, you just create a new node and move the head to point to a new node. And the new node point to Andy, right? That's pretty much the top. And then you keep doing that all the time. When you pop, you just remove your head and move your head to the next one. Like, if I pop now, I pretty much, the easy way to pop this, I just move head to Bob. Done. And then this part called garbage collection. Like, in the old time programming, you have to clean it, right? But Java actually will have GRE who will clean it up for you when the memory is not used for a while. It will just clean it up for you. Like, for example, if I keep popping, I just keep moving height, right? Down. But in array, we have to do what? If you remember, we have to do null, right? And then we have to shift them up, right? Is that right? Or we shift them up. If you remember, how did we do an array last time? Let's see. Stack. So we put null and we decrement because we said our top is at the bottom of the array, right? That means when you pop, we just always put node at the end, at the top, bottom, and then we decrement the size every time. Yeah, make it easier. Otherwise, you have to keep shifting, right? So that's how we implement array. Okay, so now we understand linked list. How would you implement one in Java? So if you look at linked list require a node, right? So you need to create a class named node. So, and you know that node composes of the data or the elements, right? And this can be a generic because the data can be any type of data, numbers, integers, string, objects, like object of users. So we make it as a generic. Now we have an element, right? So it's going to be type, right? Like Andy, right? So that's an example of element. And we said a node also have a pointer, right? A pointer to where? Next node. Then the type is a node, right? The type of the pointer. We guys pointer to the next node, right? And we call pointer. Alright, so that's it. Because that's the node, then we just need to have setter and getters the node, and set and get pointers. Like whenever we remember we change the values of the pointers, we just call setters. Right. And we need a constructor. Whenever we create a new node, we call it a constructor, right? And we pass in the elements. Like we want to create a new element, right? Which is this element. We set the element. How about the pointer? There are many ways to do this. You can pass in another node that you want to point to. Like when you create it, you can just pass in Kathy, then it's set right away. Or if you want to simplify the process, you just make the pointer to be null first, and then you can just set the pointer later. Like when you create a new node, it's just null, and then we set the pointer to point to Kathy later. Right? Are we all together? So this is just construct to create a new node, right? So node. That's it, right? Node. Now we need to create a stack. So we will call linked list stack. LL linked list. And this is generates two stacks too. Alright, how are we going to build a stack? Pretty much we try to build this guy, right? So pretty much we need to implement stack, iStack, right? Then we have to do the operations that we need. That's the benefit of using inverse. So push how will you push? We said we're gonna push pretty much first time you create a new node. Alright, so create a new node is just node, new node equals to new node. And remember we have constructor who create element first. Then this is just only one node, which is null. So at that point, if you look at the image, let's create a stack, right? So we just create a new node right there. And we pass in the element. But this part, by default, the constructor we set to null. Right? And this is just your new element. Whatever element that you pass in, we'll store in there.
So element is the data?
Yeah. Like Andy. Okay. This is pretty much what it's done. That's it, right? When you compare this statement, you get this image. Correct? Whenever you call a stack. So that means if it's just one, it's fine, because you have only one stack. But if I keep pushing, it's pretty much it's going to call itself again and create another one like that, right? If I call push again. But this time we have to check if we probably need a constructor then. Public LL stack. So we need a head, right? Remember we were talking about we need a head. So let's think about before we create this guy. What happened to the head? At this point the head has to move from this guy to this guy. But before, it's pointing to no, right? Because it's an empty stack. We don't even have this guy and this guy. That's why we want to make sure we have the head, right? Equals to no. And what is the head data type? Where is it pointing to? It's pointing to the value is null.
Node.
Yes, it's pointing to node, right? So head is a node type, right? Because it's pointing to node, right? So node head equals to null when you first instantiate an object of stack. You may say it here. Inside when you initialize the stack, we just initialize head equal to null, right? And then when I start to call push, I would say if head equals to null, I know this is going to be an empty stack, then I just going to create a node. And that's it. And that's it. No, not done. I have to move my head, right? To complete this operation, I have to move this guy to point to this, right? If it is, and then after I create it, head equals to a new node, right? That's how you move it, right? Then I get this image. Make sense? With the one element, if head equal to null, meaning empty stack, correct? Else that means it's not empty, correct? Once it is not empty, meaning when I have to add this guy in, I check, hey, stack is no longer empty. What I should do? Same thing, I have to create a new node, right? I have to create a new node, correct? After new node, what do? I have to point this to this. I have to make the pointer. Remember, we use the pointer here. This guy no longer null, but it's going to point to this guy. Then we start to create stack. That makes sense? And how would I write this code? Anybody can help? How would I write this code? The node has what? Getter and setter, right? And this is the pointer part, right? Can anyone tell me? I just created a new node, but I didn't write this arrow yet. The next line is the one that I want to do that. How do I do that? This is image that we want to create. This is the code we write to create this image.
New node dot set node to head.
New node dot set pointer, because you want to set pointer, right? To head. Correct? Because this is a head. Set pointer to head. Are we done yet? Let's look at this image. Are we done yet? Nope. What should we do next? Head, right? Has to move to the new node. Then this is the top of the stack. This is the stack, right? That's what you mean, correct? So you said we still have to do what? Head equals to new node, right? So that means it's going to be repeating every time. Let's try. If I create a new node, then I call new node. It's going to set the pointer to the head again, right? Let me move this down a little bit, then we have more room. So I push again, I pass a new element. So it's going to be like that, right? New node, push the new element. So this technically, I don't have to rewrite that because it's going to check it's no longer empty, it's going to do else it do this line. Correct? After it's going to do, this guy is a new node again, right? Dot set pointer to the head, because this is the head, right? So technically, let's do the same thing that we have done before, this guy. And then it's going to do, this one's done, right? We just did. Then it's going to do the next line, line 20. Head equals to new node. Which is technically what it does is it's going to move this guy again, head to point to the new node. And we create a stack. So it looks like it should work. We should do the unit test, right? But before we do that, let's clean up our code. We just write a program like the logically like sequence. Sometimes it's redundant. You see any redundant? No, why I have to do it twice? If I do it twice, that means either it's true or false, I still have to do it. Bring it out. Correct? Either true or false, I have to do this too. But I do that again.
Can you just not have an if?
That means just a redundant.
So just don't.
I clean it up now. The only thing is this that I want, right? Meaning what? If head not equals to null, I do this. Clean it up. Make it more efficient, easy to, It might not be the best, easy to read, but shorten it. Okay. We guys go to the same thing, correct? Any question how to push? We ready to do pretty much just the unit test of the push, right? Or we want to finish the rest. But technically, we still need one more two string. Then we see whatever we push in there, right? So how do we iterate two string? Two string is going to return all the elements in the stack. So it's going to be always a string. So we call elements string elements. Initialize to empty string first. So it's all do the same thing, right? It just depends on how you prefer. Let's look at the image again. How would you iterate through this? First, you have to set a pointer to pointer to 8. And then we're going to get elements, right? And keep getting elements. And move to the next one and get elements. Move to the next one until it's no. So how do you keep moving to the next one? Get what? Get pointer, right? So we set the elements, the pointer to start from the 8. Like we have to have the new one, right? That keep pointing to the 8 and get the elements and keep moving it down, right? Moving it down to the next one and then get elements, and moving it down and get elements until it's null. So that means you iterate until it's null, you stop. And the get elements pretty much just get the value to concatenate back to elements. And you return it. Correct. So how do we do that? We said we have to set a pointer, which is a type of that little pointer should point to node type, right? Node equals to maybe current equals to height, right? First time, right? This is just like your in I equals to 0. And then while I less than, right? Or in this case, current not equals to null. While current not equals to null, you can say current dot get element. Because you have the getters, right? Current dot get element. We want the contents. We don't want pointer.
No, the while is equal to null. The pointer is going to be null.
Right, but we want to concatenate to, we want what is in there first, right? We'll get to the other one. But now I just want to get the data, right? And you can do what? Let's do space then. New line then, because this is stacked. You keep concatenating it, right? And then what's next? You want to move just like I++, right? Current what? Dot set pointer to current dot. So this current, okay, let's move it back up, right? We were setting it to height, right? and then we get element out. Now we want to say this current should equals to current.get pointer, right? Now we set the pointer to the next one and next one until next one is going to point to no. That's why I should stop, right? We don't know if it's completely perfect until we do unit test. Alright, so we can just test with the push operation first. We go to the class, help enter, create test, right? Let's see that. Let me see one more time. Help enter, create test. There you go. I have to click on the cell, not the menu. Alrighty. So we're going to do the push toString. We technically want to use toString too, but to see if it works in the push, right? Alright, so we're going to create a new stack. This is LL stack. And the good thing is we already test our stack, right? We can use that our array stack as the expected and LL stack as the actual, right? Because we pass test with the stack, right? LL stack L stack equals to new stack. Then we start to do the push. Okay, we can start with A. B, C, right? So we push 3, right? So the top should be C, right? Alright, so we now could do what? Assert dot assert equals, and this is pretty much what? Okay, expected C, B, A, like that, right? And this is expected, which if I create the stack, right? Then do the same thing to make it as my expected, right? Because this is pretty much we tested past last time. So we do the same. Then we can have this as the actual. We can call the toString. But one more thing is you have to make sure the toString is using the new line, otherwise it's not going to be the same, right? Right, you use the new line, right? Return contents. Okay. Alright, so we're gonna run that, and what I'm going to do, I'm going to print it out, then we can see it too. Otherwise it may not be showing. Just see the stack. This machine is quite slow. Alright, so since we're waiting for that, let's think about pop. How do you guys do pop? Pretty much just return the head, right? Peak. I mean, peak is the head, right? Pop is just head. Move the head, right? Head equals to.
So we may not specify the object segment.
This is seem like it's keep iterating, right? Object type. Because I use the. It seems like maybe the loop is going on forever. One of the loop, right? We have to give the type. We call it concrete type.
Why there was no error when we don't specify the type? So we will not specify?
I think when you use ArrayList, you don't have to specify too, right?
Is it backwards compatible to order JDKs? Is that why?
Yeah. Like you can just say list equals a new array list. Just need to import it. You don't need to specify it. See that? But the problem, I think, the loop, which we will be debugging this.
I think we should move the pointer.
Like by suspecting it, I just put a toggle point. We said you should move the pointer to where?
To the next.
Alright, so it stopped there, right? C, huh? I push A first, right? This one shows C. So let's do debugger again. It should stop at the top point. Let me hover the mouse for the elements. It should show. It shows C. Current. What time is it supposed to be done? Okay. So let me see if I do step into. It seems like it's stuck in here, huh? In this loop.
Yeah, like don't you have to increment it or decrement it or something?
We try to change it, right? We said we have a current. We want to move it. Oh, that's the problem. We have to be current equals. We cannot do set because you moved a new node, right? right? Current equals to the whole new one, right? You're not setting current to point to it. So that's why. Alright, so let's start again. Yeah, that could be confusing. Right. Alright. It's better that we have to fail, not looping forever. Okay, showing difference. Oh, that's why. That makes sense because this is an array. We make it as 10, right? So if you change the size of array, it probably works, right? So, or we can add 10 elements, which we can loop, right? Let's use the loop then. For int I equal to 0, I less than.
Can we do more than 10?
For the stack, LL stack, yes. Because it's dynamically increased. But L array is limited at 10 at this point. So let's think about how can we make it dynamic increasing for array. Alright, so let's test again. Green. It works. Right? So that means our push operation works. So come back. If we want to do push, how do we do that? I mean, pop and peak. How do we do that? Or top, because top, right? Or peak. So top and peak should be easy, right? Hit, right? Because we know that's the top, right? Hit dot what? Get element. Okay, what happened? It doesn't like it. Oh, because get elements. Let's check my node. Get element. So it's about the generics, right? Required E, but seamless returns the object, so I'm casting it to E then. Hate. Oh, the problem is here, that's why. You see that when you don't do the concrete type, it's just make it as an object type to support it before 1.7. Like if you don't define type, it's already object. Right? So this one is good, is cached at the compile time, right? So you're supposed to do E right there. So that should be top. That's done for top, right? And how about pop? You remove the top. How do you remove the top? To remove the top, you move your head. Correct? So that's it. That's pop. Head equals to head dot get pointer, right? Before that, we want to return what we pop. So we have to say e temp equals to head dot get element. And then we start to say head equals to head dot get pointer. So move the head, right? So we return temp. So we return what we pop. So we're done. Now we just need to test pop and temp, right? To include pop and top. Alright, so we can move it down then. Because we already declared stack. How would you do pop? Test pop. So pretty much we already have pop that works right on stack here, right? We can just use that as our expected. Then we go call ml stack dot pop. When it's pop, it should return something. We can actually assert it, right? With what's is expected. In this case, I have A1 to A9, expected A9, right?
Then you have to take the for loop outside the push method.
Right. And stack dot pop. So let's just I guess what we need is the constructor, huh? To would it call constructor first? Interesting.
Or you can just put it inside the pop method. You can just call the push method. You have it.
Oh, you're right. I can push it first, right? It did call it constructor. So push pass. You know, you can actually go here, run the whole test. It's going to test both. You see? Pop is okay. Push is okay. See that? 3 tests passed at the same time. But this one I need to do the same with. Top, right? And right click and run the test. And we are done. All of them passed the test. Okay.
A0, right? At the top.
I mean, this is just error message that's going to pop if it's failed. But let's see. I think top is A9. Yeah.
And pop is also A9?
Yeah.
Okay.
I mean, you could just system it out to C2. I didn't do that, so. It should be A9. Top. And just run top. There you go. So that's pretty much how you do it, right? Okay, so your assignment. I mean, for the final project, we technically talked about it already.
That's for 200.
For the first part and the second part that you have to create the structure, right? Well, I said this is just an idea. You can make like ticket objects. Like ticket that store the information about the price of the tickets. Right. I'm talking about if you want to do like he has an idea of like ticket system that about the items of the product has the price.
What about the map
And then how would you store in the tickets? You may use stack to push like the first ticket come. I mean, it should be queue, right? First come, first has to be finished. Like, because we're placing an order, create an invoice ticket. Ticket is an object that's pushed into the queue. So you implement the queue. That's assignment 1 and 2, combining toward your final project.
How do you put the maps and stuff in there? Do you have to put the maps and stuff?
Oh, that's going to be coming in when we talk about graph.
Okay.
You can use Google API to embed the map into your code. Let's use the library. Now for your... Oh, let me do the... Chapter 20, right?
Yes.
You can get your class, the questions. Do we have enough questions for this one? Think so, right?
How many people do we have in class again?
We have class again on Monday, right?
How many people do we have in class? How many problems do we need?
We should have about 23, 24, like the map is 25, so
22 questions.
20?
Yeah, I think so. They have 23 in it.
Yeah, I think it should be enough. Like same, if it's not, you go for the next one. It's probably one student or two. I think we have about 23, 24. So in this chapter it starts to talk about list, stacks, queue, right? Which we talk about that, right? Now, what is a priority queue? Okay. So what's a queue? A queue, you already know it's like at the cashier when you check out, right? That's the queue, right? It probably everything is pretty much the queue. First come, right? First in, first out, right? First come, first serve, right? But there happen to be a priority queue. They look at the priority now. Even you come first, but you have, like when you go to like Six Flags or Busch Garden or Disney, you didn't pay for the priority ticket. You still have to wait. Right? So if you happen to be in the queue, but you have a priority, then you go first. Like you're waiting in the hospital to see the doctor, but someone has an emergency, then you have to go first. That is the priority queue.
So with a priority queue, you can set different priorities and different elements.
Yes. And then based on that priority, then you do it first. So let's jump to that priority queue. This is just showing you again in the list that we mentioned. Oh. Right, this is, you can go back and review. I just talked about collections, if you remember. Extend the list interface, right? And those are the operations. It's just more than just one add, remove. So one more important thing that you want to focus is on page 772 here. When it started to talk about comparator. Remember, if you do order list, you have to compare between two elements, right? Or objects. So the objects, how you can make the object to compare. Think about if you create a user class. It's just like string. You have the method called what? Compare to. If you don't implement that, then your object cannot be compared. How would you know that student named David is less than or greater than student named Andy? You have to tell like, because student class has many attributes, right? It could be age. Are you comparing by the age less than or greater? Are you comparing by the name alphabetically? Or are you comparing by the grades? It had to be implemented in your code in a compare to. So comparator interface very much you need to implement it. Okay. They have. Let's look at comparator interface. Right there. Right. So this interface has one method called compare. Okay. But they have comparable interface. Comparable interface has one method called compare to. Like toString is using comparable. So that means your object, if you want to use like compare this to another object, then you're going to implement comparable once you create your object. Okay? But if you want to implement comparator, that means you compare between two objects, not like this, right? Two, right? Because this is only one parameter. See that? Just like toString. Returns negative when it's less than, 0 when it's equals, positive when it's greater than. But this is you return like the same, but it's compared between two objects. Okay. Alright, so you probably want to implement that in order to do the order list. I think we should be good for today. Okay.